Before we get into any formulas, let's just explore a simple series. So in the previous video, we learned how to expand out any series. So in this one, we have a starting value of n equals 1, and we're going all the way up until n equals 100, and our equation we're using is just n. So if I were to expand this out, it would look something like our first term is 1, our second term would just be 2, our third term is 3, and so forth, all the way up into our last few terms, plus 97, 98, 99, and 100. And that's where we would stop. So I could type all of this into my calculator, but what we've discovered through Carl Gauss is that there's actually a formula I can use to do this a lot faster than typing out 100 numbers into the calculator. So we're going to look at that for a second. First of all, this is an arithmetic sequence because to get from one term to the next, I'm adding 1 every single time, which is the definition of an arithmetic sequence, is you're adding the same value to get to the next term. So that's an important concept to know. Secondly, we're going to see if we can find any patterns here. So if I look at my first term and my last term, 1 and 100, I know that 1 plus 100 is 101. If I then do that again, if I look at my second term and my second to last term, 99 plus 2 is also 101. And this is what Carl Gauss discovered. He's like, wait a second, if I do that each time, 3 plus 98 is 101. So how many times am I going to get 101 if I just arrange this? Well, if there's 100 terms total, then I'm going to have 50 pairs of 101. So instead of adding up 1 plus 2 plus 3, I can just do 50 times 101, and that's going to give me my answer. And that comes out to 5,050. So let's test this on a different arithmetic sequence. Let's say we have the sequence 2, 8, 14, 20, 26, okay? So I know this is arithmetic because every time we're increasing by 6. And I want to find the sum of all of these numbers. So same kind of process. If I do 2 plus 26, that is 28. If I do 8 plus 20, that's 28. And I have an odd amount of numbers, so my last number here is 14, which is exactly half of 28, which is going to be interesting. So altogether, I have 2.5 pairs of 28, and 2.5 pairs of 28 would be 70. And this one we can add up a little quicker so you can verify that that's true. 8 plus 2 is 10, plus 14 is 24, plus another 20 is 44, plus 26 would be 70. So now that we've explored a couple arithmetic series, let's go ahead and put this to a formula. So this formula, S sub n, just represents the sum of n amount of terms, and then n would be your last term. Okay, so this is your total number of terms. And then as in the other formulas, u1 is just your first term and un would be the value of your last term. So we're going to get to this in a second. You see here there's two formulas, but these formulas are essentially the same thing. And let's see how we get from one to the other. So if you remember from arithmetic sequences, I can define u sub n as u1 plus d times n minus 1. That's the formula for an arithmetic sequence. So if I substitute this into my formula up here, I get n over 2 times u1 plus, instead of un, I could write u1 plus d times n minus 1. And that exactly equals my formula over here. I have 2u1 plus d times n minus 1. So they're the same exact formula. Some of them are just easier to use depending on what information you're given. Okay, so let's get into this. So in the previous page, we talked about this series right here, and we came up with our answer. But let's go ahead and just jump right into the formula now. So if I wanted to find the sum, I would just have S sub n would be, there's 100 total terms, so 100 over 2. My first term I get by plugging in 1, so my first term would be 1. And then my last term would be by plugging in my top number, so my last term would be 100. So that means the sum of this series would be 50 times 101, which should look really familiar. And that comes out to 5,050, like we discovered before. So let's do a couple of examples. So in this one, we have an arithmetic series, and we want to find the sum to the 12th term. They're given right here. So for our sum formula, we have n over 2 times the first term plus the last term. So right now, we are missing what our last term is. We know that there are 12 total terms. We know that our first term is 290, so we just need the value of our last term, which we can get based on what we know about arithmetic sequences. So we find u sub n, by taking u1 plus d times n minus 1. So u sub 12 would be 290. And then let's find our common difference. So if you remember, that would be 278 minus 290, which is negative 12. So this would be minus 12 times 12 minus 1. So u sub 12 is 290 minus 12 times 11. So, 290 minus 132, and that comes out to 158. So now we can go ahead and plug into our sum equation. So back over here, the sum of our 12 terms would be 12 over 2 times our first term plus our last term. So then we would have 6 times 448, which comes out to 2,688. So that would be our sum. Okay, so for this next one, we want to find the sum of this series. So again, if we write out our formula, we have that Sn equals n over 2 times u1 plus u sub n. So because of the way they wrote this one, I'm given my first term and I'm given my last term. So I actually have u1 and I have un, which is 40. What I don't know yet is how many terms there actually are. So we're going to have to figure out what term 40 is equal to. So to do that, again, we're going to use what we know about arithmetic sequences. So we know u sub n is u1 plus d times n minus 1. I know that this is 40. This is 7. My common difference I can find, 10 minus 7 is 3. So 3 times n minus 1. And I can use that to solve. So then I get 33 equals 3 times n minus 1. Dividing by 3, I get 11 is n minus 1. So n would be equal to 12. So this would be my 12th term right here. So we're going to use that now to plug into my sum formula. So S sub n, there's 12 total terms. My first term is 7, my last term is 40. So we get 6 times 47, which equals 282. That's it. So in this video, we learned how arithmetic sequences work, thanks to Carl Gauss, and how to use the formula to do arithmetic series faster. Thanks for watching.